everybody. It's molding day. Can you guys hear me? There on the peanut gallery.
Which I think is Emma.
Which I think is Emma.
Yes, I can hear you.
Okay.
Yeah.
Cool. There we go. All right. So we were going to just do a general concept overview and then do some hands-on work, some of which will be up here and some of which will be down in the space. So I have several molds that I will pass around to all three of you. Usually take a look.
People usually show up.
Yeah, when the time comes, because it is kind of a very hands-on sort of thing, mold making and casting. So without further ado.
Yeah.
I got it. Okay, so one thing that we're gonna kind of avoid is getting too far like down into the weeds. So when you guys have individual projects that you want to discuss, we can absolutely deal with them on a case-by-case basis, but we're going to just sort of do a very like general overview, and then you can deal with me one-on-one for individual projects if they're not covered or you have questions, things like that, because it's a situation where like every single mold is kind of unique in its way, and so best to sort of like deal with it in that way.
So
we're gonna
just the big ideas.
Yeah, the big ideas. So it is definitely best learned hands-on, and there's a lot of different permutations. If it's easy to sort of get ahead of yourself, so when you're starting out, simpler is better.
Yeah. We just made some simple demos for downstairs so that it'll be delightful.
Yeah, and after it does get like exponentially easier as you go along, like after you do your first one or two, then it starts to sort of click. So definitely we're starting out with the basics. So definitions. Something that frequently happens is people mix up terminology when it comes to the whole process. A mold is a cavity, a casting is a positive. So the mold is what you use to make the copies or the casts or castings. And a lot of times people will sort of flip-flop those terms and it can get a little confusing. So the mold is the hollow thing. If you're looking at our little cherry example there, it is the hollow structure that is used to make the form, which is the cast, which is the cherry itself. Okay. And a mold is like, I love the bronze age spear molds that Corey cooked up there. It's been these processes, a lot of them kind of haven't changed in thousands of years, which is really cool. And there are kind of molds all around us. Like if you've ever made muffins or cupcakes or candy, you've used a mold. Like at the core, that's what the principle is. So the design of a mold is the thing that's gonna influence your outcome the most. And there's a lot of different factors, but it'll affect the quality of your final product, meaning how good does that thing look, that cast that you take out of the mold? Like, is it messy? Is it full of bubbles? Is it clean? Is it, does it have the surface you want? The amount of material you use, mold making and casting materials can be expensive. And so there are ways to design that will limit the amount of material you need, but it will probably take you longer to create the molds. And then there are some that'll be much faster to make, but you may end up using quite a lot of material. And there's always going to be trade-offs. Taking the time to plan is the most important thing, because if you rush or you're unprepared, you can end up wasting material, and that is always a very, very sad moment. The design really affects the time that it takes you to make each individual cast once you start actually using it. And one thing I will harp on quite a bit is that any small thing that you have to do during the course of molding and casting, like it becomes more and more and more of a time, like kind of like a black hole of time. Like if you have to clean something up off of your cast because you didn't take the time to make your mold properly, that will kind of snowball over time, and you'll end up spending an awful lot of time doing that rather than taking the like initial moment to do it right the first time. So Yeah, I mean, there's a lot more, but that's the basics.
The thing that
Yeah.
jumps at me with this
Yeah.
is really like, these materials are oddly expensive.
Yeah,
It doesn't, it just sneaks up on you.
right.
And so the more you can plan to like use less material, the better.
Yeah.
And I have no idea why this is what's in my head, but it's like in order to save water, we put a brick in the toilet
Yeah.
tank. Is that maybe that was just my house as a kid?
Displacement.
100%.
Yeah,
Yeah.
well, yeah, and that concept is essentially correct. I think I showed you guys a spreadsheet that I made when I was doing block molds, which is just sort of a box filled with goo. And when I went to figure out the amount of material I need, I changed the minimum thickness of the mold walls by like 0.1 inches, and a single set of molds ended up costing me $200 more. Because it just it enlarges the overall volume of the box you're dealing with, and it's sort of hard to wrap your mind around that. I do have some examples here where I'll kind of show you guys how much rubber it took to make a mold of this essentially skinny little thing, just because it was a strange shape. So
In any case.
yeah, moving on.
Speaking of,
It can go on, yes. So essentially, unless your mold is ultra perfect, either the mold or the casting has to be at least somewhat pliable. It's got to bend a little, or you end up messing either the mold or the casting or both up when you try to take the thing out. Okay.
Yeah, it's a great rule of thumb that one of the two has to bend. Like
at least a bit.
Think about making cupcakes. The cupcake is squishy, but the
The tin
cupcake
is
tin
rigid.
is not. If you're
Yeah.
making candies, those are always silicone molds
Mhm.
because the candies are hard and the silicone will bend.
Something's got to give.
Right.
that's fair, makes sense.
Exceptions to that rule are, like you said, when it's a company who paid 10 grand just to make the injection molding form, then they can be perfect and it's fine.
Well, and that comes down to like the thing you're making was
Right.
engineered to be easy to cast.
Right, and that's a different.
Most of the time, that's not what you're doing.
We're not playing that game.
So most of the time, the mold material is the pliable thing. It'll be squishy, and I can,
Or it could be disassembled.
yeah, or it comes apart. And that's the majority of the time, that's going to be what happens. And the more crazy your shape is, the softer the material needs to be to make it work.
Yeah.
If not, you run into issues.
Yeah.
It can damage your castings as they're coming out, or damage the mold itself. And that's also something that will cause wear and tear on the mold.
Yep. These are all small ones.
Mhm.
This, I made a concrete countertop. We'll talk about that more. But this comes apart. I made a form that was all screwed together out of melamine and then disassembled it to get the countertop out. It was great. It's probably still in that house in Cleveland, but just because it's so heavy, I
Yeah.
can't imagine them wanting to move it. It was a lot.
Sometimes the casting that's coming out is squishy, so the molds can be rigid. And I actually have an example. These are some casting, the same thing that I did for a project where I had to make copies of these little like bodies over and over again. And one of them is made of plaster, so it's rigid, and the other is made of rubber, so it is soft. And you get the same result, but the materials vary. So it kind of depends on your use case, but it's kind of fun. And this is also when we get into ceramics, the way that ceramic slip casting is done, because those molds are plaster.
All these things would have been
Yes,
cast.
these would have been cast.
Yeah.
So it's a dumb question,
Yeah.
because I was late. Casting comes out of a mold.
Correct.
Yep.
Yes. Yeah.
That's the key.
The
That's the
mold
key
is the
term.
cavity, the casting is the positive, so it's negative and the positive. So this is it's kind of hard to parse what you're looking at, but this is just a classic waste mold, which is a really, really old technique. Like, it's been used for a very, very long time. And that's basically taking your soft clay original most of the time and making a single use mold where the original is pulled out of a rigid plaster mold. And it gets kind of messed up in the process, but your mold is good. So you take the clay out and then you can make a casting, filling the mold, and then the mold has to be chipped off of the cast. So you get one shot. But if you don't need a ton of something, like if you're just trying to make something archival that wouldn't be otherwise, because like a lot of times I'm a sculptor, a lot of times you're using a clay that won't dry, like an oil-based clay, you have to make it last, and so it'll be transferred into plaster using this, and it doesn't cost much.
Can I try and reinterpret this process as not
Yeah.
an artist? Okay, so Julie made this very incredible thing out of soft, pliable clay with
Mhm.
tools and like scraping and sanding and doing whatever you needed to do. Then you make this plaster negative
Yeah.
of that shape
Mhm.
so that you could clean out all the gunk. It ended up destroying the original
Yeah,
thing made out of clay.
bust it up. You can
Yeah.
see right there the little boxes.
But the point was so that you could make it out of like something some very nice material.
Yeah.
Some very nice plaster, or like if you wanted to do a resin cast of that, you could, but you get
Yeah.
one shot because it's a hard material that you have to destroy.
If your mold gets messed up in some way, you risk losing the piece. That's the one thing with these. So it's a pretty repeatable process though, so there's usually not a ton of surprises.
Yeah.
So another waste mold is alginate, which is the stick your hand in a bucket of goo. It's derived from algae, so it is really cool, really quick to use, and it starts degrading like immediately. If you've ever gotten impressions taken at the dentist, that's what they use.
And what we may use later today.
Yes, exactly. It's an easy thing. This is showing a time lapse or like a little GIF up here of me taking apart the molds of this gentleman here. He's the pops conductor for the New Haven Symphony Orchestra, and I was doing a piece for them. So dude had huge hands, big bucket. But I was able to get casts of both of his hands and then mount them later. But this is plaster. Had to be immediately cast into the bucket, and then later when it set, I took it apart, and that's how it was made. So a much more time intensive process. This is a different kind of mold that is using a silicone rubber, and it's called a layup mold because the mold has to come apart into multiple pieces, and it was very, very important because this was a prototype. It was made 3D printed, and all the parts were like had very precise little keys that had to go together, and so I had to make sure that the castings were going to be very, very like reliable. And so the way that you do this is by putting your piece up to the exact halfway mark, the parting line, in a mold making clay, and then you fill and you use impressions to make these little nubbly bits, which are the keys, so that it registers later. But then you backfill it with rubber. Once that sets, you take it apart and flip it upside down, remove the clay blanket, and then you apply a mold release. Here you can see the sort of greasy sheen on there, and pour the second half, and then it'll come apart perfectly at that line. So this is the very, very like nice, perfect production molds kinds of mold, and it will take much longer than some other types. You get great results.
And the layman's interpretation, once again, Julie made those in this top number one. Julie made these gray things. Those are original art. The tan color stuff is just a clay underneath with a whole bunch of dimples in it. And the whole point of this clay bed that it's laying in is so that you can pour silicone. The silicone fills in all the dimples, and you can pull away the clay. Once the clay is removed, you make the whole thing covered in mold release so that you can just do another round of silicone. So that's why these look like mirror images.
Yep.
So one's the top and the bottom, and then you get your parts out of it.
Yeah. Silicone does not stick to many things, but it does stick to itself. And so this is a situation where mold release is critical. We will talk about that in a moment.
Yep.
You said something about the exact halfway mark,
Mhm.
and I'm trying to see where something gets like sunk in halfway or poured in halfway or.
Well, what it basically is, if you imagine like a blanket of clay.
Yeah.
If you were to squish the part down just straight, it might or might not, depending on the topology of the piece, it might or might not be actually hitting at the halfway mark. So you end up kind of tooling the clay up to that line all the way around it. And so that you can't exactly see it here, but the clay is sort of following along that midpoint rather than the other way around.
This is
So those on number one, those are halfway covered with clay.
right.
Those are halfway covered with clay.
Okay.
And right here, right below it, after that's poured, the rubber has taken the place of like the clay. And so then you do the second part.
And it's interesting. So this is like a flat wing,
Mhm.
roughly flat, but see how the material is not a straight line on this side? It's because it's following the contour of the wing. And so that's, you're like finding a seam, like you've
Yeah.
all had some crappy plastic toy where you could clearly see the seam. This is planning for where that seam
Yeah, you're
belongs.
trying to avoid seeing the seam by doing it this way. It gets you a much cleaner seam line where you're not going to have a ton of flashing.
Like if you're making dice, you want your seam line to be on the edges,
Correct.
not like in the middle of a face on the dice.
It really influences, taking the time to do it this way influences the amount of cleanup it takes per piece. A lot. So if you're making a bunch of stuff, you take the time to do it this way if you want to avoid having to sand for the rest of your life.
Yeah. Okay.
So choosing your materials is kind of one of the most daunting things initially, and it's really easy to go down a rabbit hole here. But when I say start simple,
Just gonna go down this rabbit hole.
yeah. Starting simple, starting with a simple molds and a simple mold making material like a rubber that's intended to be easy to use is always going to be the best way to go. And then you kind of back it up from there. So every application, there's going to be a type of mold making material that's probably going to work better or best compared to other things. And you have different properties that are going to affect that. So
That like list of menus, those were all versions. This is one of the things that we used for the composites.
Yeah.
Like there's so many options. It's a real
Baffle.
it's
Yeah.
yeah.
It can be, but once you kind of know what you're looking at, it becomes less baffling, and I hopefully will be able to explain this. So food safety will dramatically limit the amount of materials that are available to you because that is an actual certification. So if you're doing something food safe, I'm just going to say this outright. If you have a project, call the manufacturer. They always have a hotline. Be like, hey, this is what I want to do. They will make a recommendation. Bother them. Trust me. Even if they
Smooth On has people for
Yeah.
that purpose. Like that's their job.
may not recognize my voice at this point, but
Mm-hmm.
there's levels of like hardness or firmness to the material depending on what you need it to do, if it has to perform function.
And we have testers for these downstairs, so you can like feel how hard or rigid or squishy the things are.
Yep. We have a lot of smooth on products. You don't have to go with them. We just happen to have them because we've been using them for a while. Whether you have some sort of effect you need, like clear or opaque, and with rubbers, sometimes there are clear rubbers that are useful so that you can see what you're doing if you're cutting it open in jewelry practices or something like that. The most important things by far are going to be your pot time or your pot life, and then your cure time or your set time. Okay, so those things affect yes, okay. So okay, pot life, that's how long you have to work with it. There are some resins that have a 30-second pot life, so you got to be really sure you know what you're doing before you use something that cures that quickly. There are others that are a lot longer and give you much more leeway, especially when you're starting out, but they're going to take a little bit longer to fully harden or cure because it's a chemical process. Okay, now like these are all epoxy.
2 seconds.
Yeah, 2 whole seconds of pot life. The instant it's out, it's done. You know,
But that's a spray.
that is a
right?
spray.
It's a spray.
and that's a feature because when you spray it on, you need it to set immediately, or it's going to fall off of, because that's for like vertical surfaces. Okay,
If it was 8 seconds, it'd be a problem.
so it's all, there's all these different formulas. The funny thing is like these materials are all kind of basically the same things at their core. They just start fiddling with their features. Okay, now for you guys over here, like the viscosity on the left, mix ratio by weight and volume, pot life, and cure time. Those are gonna be the things that really, really matter to you as far as workability goes. Basically, is it gonna either like gel out or create a bubble through, like, is it thin enough to let bubbles out, or does it stick to a vertical surface? That's the viscosity. The mix ratio, if you're mixing by volume, usually that's a much simpler material to use. It may not have as many crazy like properties or specific properties, but it's going to be designed to be easy to use. And I would highly recommend things that start off mixed ratio by volume. When you get into mixed ratio by weight, frequently you need a gram scale and you have to be more precise.
Often these are close. And like
Yeah.
for these easy mix ones,
Yeah.
here it is like this is 1-to-1 and 1-to-1. Here's 1-to-1 and 1-to-1. But much to the dismay of chemistry students everywhere, density is a factor that you have to plan for.
Yeah.
So even though they're the same volume, they have different masses.
Correct.
So like the part B has a higher density than part A. So
and in case I didn't mention it yet, most of these are two parts mixed together to create the curing reaction. Okay. So the cure time over on the far side here, that basically is like how long before you can take the thing apart and use it. And that can matter, you know, if you're on a deadline or you just want to kind of get on with it. There are some that are 30 minutes cure time, and there are some that are 24 hours, and that, you know, is a factor. And then if you see, like, we'll go over like the properties probably of the casting materials in a little more detail next week once we get into that. But generally speaking, the longer the cure time, the more specific the material is. Like if you have a very, very long cure time, it's for a real specific application. And you're not going to deal with that often. Most of the time you're dealing with like a few minutes to a few hours to maybe a day. Okay. So there are reference materials that we have downstairs, and I am one of those. So you can always you can always you know, hit me up on Slack or something if you have a question. The short hardness scale, which I think we'll talk about in a second.
well, it's fun.
Yeah.
It compares basically.
Yep.
This is where my chemistry teacher's self starts talking, is that you've got when you're looking at mixed ratios, you really need to pay attention to that. If you do it the wrong way, you'll part A or part B will run out before it's supposed to, and then you'll have leftover of whatever part didn't run out.
Yeah.
And
it might not work.
Yeah. So you really, really need to be careful about getting them to be about very close to target. Especially if you find that you have a really unequal mix ratio. So 1-to-1s are great because they're off. If you're off by a little bit, it's not that big of a deal. But if you have something that's 5-to-1 and you're off by a little bit on the part that's the 1, so a little bit off on the smaller part makes a big difference.
Yeah, it can. And fully mixing, I cannot stress exactly how important that is, because the amount that sticks to the side of a container can influence the outcome. So you got to be able to scrape it and mix it and like really, really get everything. Just
to define these again.
Yes.
Hot time is the time you have to mix and handle it. Cure time is how long it is until it's done. And exothermic reactions are pretty much what all of these are. Those are chemical reactions that give off heat. And you have many of them in your body. We are warm-blooded. Our bodies, by doing their thing, give off heat. And so do these reactions.
Yep.
One of the things about these, though, is that they don't know to go to a cooler space when they get hot. It's just a pot of chemistry going to do what it does. And often being warm accelerates chemical reactions.
Or heat go faster.
Right.
And
so it can be a positive feedback loop.
Yes.
Where the resins, if they're heating up because they're reacting, and then you keep them in the same bucket with all the other resin that's hot, you can get a fire. That's actually pretty scary.
Yeah, it's remarkable how hot they can get. And there's ways to manage that, but you guys have to keep in mind that most things, you know, most resins, when we get to casting, are going to be exothermic, and the bigger the bucket, the faster it's going to go, and it will really speed up. And that's when you run into a situation where the entire thing just sets really quickly when you're not ready for it, and you lose material. So we will try to avoid that. So
More,
yeah, the mixed
This-
ratio, how much A to B.
yep. Viscosity is how much internal resistance to flow there is, how easily it'll move around. There's CPS are the units that they use, and one is water, 2000's honey. Ketchup is 50,000. The silicone can cover a huge range. So using the numbers to your advantage will let you get the right amount of weird rubberiness you want.
Yeah, and like really, this is sort of like a mental exercise. Like I don't remember like what 14,000 centipoise is like, but when I look at it, I'm like, okay, it's like canola oil. I go, oh, okay. And then I think, is that going to be like runny enough to do what I need it to do? Like that's sort of like, think of it in real world terms, because this is stuff people all use. The numbers may eventually start making sense to you, but I usually just use the example. And then shore hardness is just there's two usual scales, A and D, that we use. It's just the hardness of a squishy material is shore A, the hardness of a harder material is shore D. And that can affect like the rubber you choose, like how soft it is.
Like there's rubber, think about different options for rubber wheels for casters, right? Like there's the soft rubbery ones that like you're not super upset if they go across your feet. Then there's the rubber ones that are like meant to roll around on concrete all the time. Those are both rubbers, but they have to have different hardnesses to deal with their scenario. But realistically, what we have found is that there are many questions, but you will find the way.
Yep.
With eventually you'll get there. You'll just need to think about how many copies do you need? What's the final material? How complex is the pattern of the thing? How big and how large is the object? How much cleanup do you want to spend on your each individual time you cast it? How are you just burning time, or would you rather throw money at the problem? And how like advanced of the chemical sets do you want to go? Do you want to do one? There are some that are I've seen 1 to 98.5, which is wild.
Yeah, I mean, truly, like with mold making, the first question you ask is how many do I need, and do I really need to make a mold? Like, not that I want to dissuade anyone, but frequently it may not be the best option because there is no such thing as a quick mold. It's great for certain things, and if you have a real specific need, that is, you can easily make a mold, or not easily, but you can make a mold that can get you any outcome you like. It's just a question of how much investment it is. And the time versus money investment is always going to be the thing. But I would just say don't skimp on materials to save a little bit of money. That is the number one reason that molds fail. So
Yeah.
yeah.
The Mandalorian.
Yeah.
There's a teacher at my middle school, at a middle school where I teach, who actually cast that and made her own Mandalorian head.
You
It's
absolutely
really
do that.
good.
People use mold making for tons of like cosplay, costume, and all sorts of stuff. It's very cool, and you can get, you can make it look like real metal and use real metal. You can make it glow in the dark. You can do any number of things.
She brought it to school on May the 4th.
Yeah, that sounds right.
There are some things I will say, if you're gonna do a mold for something really heavy like concrete, that is one thing that you want to take special care with, because think about like how much a bucket full of like packing peanuts versus a bucket full of like sand or rocks is, and how much strain goes onto the poor bucket, so
That countertop was 800 pounds.
yeah.
Yeah.
It's a factor.
It was a lot of friends to help move it into place.
And again, time spent in cleanup becomes like kind of a snowball effect. So that goes back to the how many do I need and how much work am I willing to do. Anytime you say, I'm just gonna cut a corner with the mold, you will have to pay for that later one way or another. So yeah, and right now be kind to yourself and go with very straightforward materials until you kind of get the hang of it.
We have a couple examples downstairs that I should have grabbed that are just like things to make casts of later. And we're gonna try and make molds of them soon or throughout the week. But they are coins, you know, like circles of wood with a raised structure, nothing fancy, just like a coin because it's very flat. You don't even need to close in the back. It can just be, if you don't care what the back looks like, you can just leave it flat, and that's fine.
Yeah, and something for molds that's just really fun. These things are used, these are molds to make rubber feet for the vibration table that I have downstairs, and I made a couple of 3D printed ones. So the castings were soft, so these were rigid, and then I used alginate to copy them so that I could make more. So this is a plaster mold. You can just sort of use it as a technique in your wheelhouse to transfer things into new materials and like speed up your workflow when you're prototyping or doing anything else like that. So if you guys get a chance to see these, that's something I do a lot. It's like moving materials from one to the next.
Another thing that you may need to think about is are the gases that are contained inside your materials. And ultimately there's two solutions to this. Because I'm a chemistry teacher, every chemical has a vapor pressure and it wants to turn into a gas. And you can either help it do that with a vacuum pump, where it sucks out all the air. And then any of it that was going to turn into a gas does and leaves, so that you're left with no bubbles in the material. And that can be a great way to do things. Especially if you're doing resins, you may try and pull out all the bubbles, all the volatile parts before you pour it, so that it doesn't have bubble making parts left in it. Or if you can fit it inside the pressure pot, you can actually cast it inside of a pressure pot, and then that will add enough pressure that the bubbles don't form, and you sort of collapse them in on themselves, squishing the bubbles instead of letting them form.
Yes. And you're in mold making and casting, your number one enemy is bubbles. Always bubbles. Like there's just entrapped air. Yeah, you're always trying to get them out of there. And pressure is a great way to do tiny things with little details that you really need to force the material in to get all the detail. Vacuum chamber is great. That's how I did this mold, which is pretty much bubble free. Couldn't fit it in the pressure pot, but vacuum degassing got pretty much all of the air out of that for a really, really nice mold. And both of them are viable. The one thing I will say is that if you plan on pressure casting, you must make your molds under pressure. The mold has to cure under pressure in order to be able to cast under pressure. Otherwise, if you use, and this is an extreme example, this is a very bubble filled piece of rubber here. If that were cast under pressure, it would force all of those bubbles full of material, and it comes out, the casting would come out looking like a pickle. So it's not great. It's fine. It's actually a lot more disturbing than you think, but that's just a really air filled mix. I don't know why. So shapes, draft angles.
So when you, because bubbles are the enemy, you often will see things that happen for practical reasons. Like the Rolo candy, which is not a cylinder, it has that taper because it makes it easier to mold.
Yep.
The gases can escape and they can get them out of their container with very little effort because it's that shape so that gases pass in and out the way that they want to.
And you could use a rigid mold.
And
you're probably done with like steel.
Yeah.
Crazy quantity.
I'm sure they are. But then you've got these sprues where you can get, down here is the inlet where the material is poured in. And then here's a sprue on the bottom. So any gas that you had inside the cherry or the stem, the gas could exit through this sprue. So you need to make sure that if you're pouring material in, there's a way for the gases to get out.
Oh, that's not where you pour it in.
No, you pour it into the bottom.
Oh.
So you pour in all the goop in the bottom,
Yeah.
and then it runs down through here. And if this sprue wasn't there, it just wouldn't go into the stem.
Bubble, yeah.
Yeah, because you just have a big old bubble.
And this is probably that's probably a hollow cast, which is how they were able to do that. It's kind of like plumbing. the material has to go in one way and it kind of should push the air out. So the air needs a place to go, because if not, it gets trapped and it'll create a void in the casting.
When we pass around the hands, you'll see that there's a pinky that has a bubble because it didn't have anywhere for the air to go. It just got stuck.
It's this one, yeah. Let's see. Air got trapped there. And then this
So it's
one
like a
turned out, well,
indent
we had
in
to
it?
backfill the
It's like
phone.
flat. It's weird. When there's bubbles, we're gonna try and do thumb casting before we leave. So we need to keep going.
Yes.
But if you get a bubble in the mold, you'll get a little lump on your cast. And if you get a bubble in the cast, you'll
You
have a
get a
hole.
void,
You
yeah.
get a void. So
Okay, really important. So cure inhibition is when the mold material, usually silicone rubber, comes in contact with something, usually either sulfur or aloe vera in some cases, that keeps the cure from happening ever. Meaning it'll just stay goo. Very sad.
yeah,
You're a sad
Very.
Lego person.
Very
yeah.
sad.
Okay.
Mhm.
Yeah.
It
Chemistry.
interrupts the chemical reaction,
Yep.
and so it doesn't fully set.
And that also can mean silicones will usually stick to each other, but there are certain types of silicones that will inhibit each other. Like a platinum and a tin cure silicone side to side can cause problems. So you need to double check before you mix and match. And never ever use sulfur clay if you plan on molding it.
Yeah, there's, for all the delightful charm of a messy artist station, this is one thing that has to be very carefully managed.
I don't even allow it into my studio.
Right. It's, you just have to plan for it.
Yes.
And then release agents.
Yes. Yeah, it's something that keeps things from sticking to each other. And
We just sprayed, there was some downstairs, we just sprayed it.
yep.
What's it often made of?
Usually there's like the sprays will be like oils and silicones or waxes. There's a lot of different things. You can use Pam and this, like spray Pam in a can for a lot of things. Murphy's oil soap. Baby powder is a powdered release agent. The one thing I just want you to say is that don't forget the release agents, but also remember that if you need things to stick to each other, you have to make sure the release agent is not there. Sometimes you do want that. And do not spray release in the wood shop. You will ruin people's projects because it'll mean that they're not going to be able to get a finish on their piece because the varnish or oil or whatever is not going to stick. I can't stress that enough. That's like, just be a good neighbor.
Our
Don't
big vacuum bag for composites probably didn't stick together on that one side because
there was
some mold release on it.
Yeah.
It does a really good job of making things not stick. And so you just got to plan for it.
Yeah, but inversely, if you're doing molds, like if you're doing a mold where you're brushing on layers, which sometimes you do, if it's in a dusty shop, that dust can keep those layers from adhering to each other. So you just kind of want to consider that as a feature, I guess, of the atmosphere.
We sort of touched on these. Yeah, open face molds we've looked at. These are basically Rolos and other chocolates. If you don't care what one side looks like I did not care what the bottom of the counter looked like, you can do it open face, and that's great. You don't have to worry about the other surface. It's going to look bad. The top of the counter was on a melamine surface, so when it came out, it had the surface features of melamine, which is like a nice, slightly bumpy texture that is actually a really nice countertop. When they pour and for chocolate candies, you usually don't care what the bottom looks like. If you ever I'm sure we've all gotten a box of chocolates for yourself is totally allowed. They always package them right side up so that you can see the nice part and you're not looking at the bad part.
And the thing with molds, they give you what you give to them.
Yeah.
Like for the most part. So
like a thumb.
Like a thumb.
This is what we're hoping to do today, where
The cups are full.
that's what the cups are for. This is my thumb and this is the cast. You can see there were bubbles here on my thumb. But this is the mold of my thumb. And then we poured plaster in. This is plaster. It looks oddly skin tone, but it is plaster. But this is actually a really quick, simple process. When we start mixing, the molds will happen in 8 minutes. So if you want to stick around,
real fast.
it's really fast.
And I do have an example. I was going to do a small pressure cast mold downstairs that I have set up. So that
Mhm.
you guys can see that process while you're sitting there waiting for crayons
Yeah.
to set.
The more advanced thing is a two-part mold.
Yep.
And this is really the one that Julia has been so good about showing, is that you have these little registration marks that are all over the place. Here's the mold seam is sort of highlighted in pink. You can just barely see it. The inlet or the reservoir where you pour the material in, the sprue going out. This is really sort of the core skills that you'd want to have if you wanted to make a two-part mold. And my as not the artist in the room, my genuine suggestion is don't do this first.
Yeah.
Do an open face mold first. It's
Like,
much easier.
You're not, this is called a cut mold, and you guys, this really big heavy one right there is also, that was cut in a bunch of different places. It's where you make it a big block and then you cut it open to get the thing out. It's kind of a squiggly, messy seam, but it can work. So if you want to sort of graduate to this, you can do it. When you're building them to come apart, the engineering gets more intense. But there's a way to do kind of anything. I would just say that start out slow.
Yeah.
And once you do one, it gets a lot easier.
And if you're trying to look for
It's
examples,
messy.
yeah,
Check out the injection molding.
that's true. That we're not going to do this, but this guy is great. It's the engineering guy on YouTube. It's worth watching. I'll put this video in Slack because it's every plastic piece you've touched today was probably injection molded.
And this is a great example of like the object being engineered to be molded easily, because it
Right.
has to be. 'Cause
Right.
The casting and the mold are both going to be pretty much rigid.
The Lego,
It's
the
very
plastic,
cool.
the plastic chair. You'll notice Legos don't have the draft angle that Rolos do. However, inside they do. So they can be rectangular on the outside, which is kind of wild. Legos are a fascinating thing to have engineered into existence, and then people go nuts with them.
And they work great as mold surrounds.
Yeah, because they have good
They're
seams.
strangely watertight.
Yeah.
It's
Yeah.
really cool.
So the video is great. We're not going to watch it here, but this is worth watching just because it's so common in your everyday life. And then vacuum forming.
Yay.
You can also make molds this way if you have some object that you want to vacuum form.
Great for candy.
It's great for candy. It's great because you can just make like a rectangle and then cut out wooden letters of your name set on top of the rectangle, vacuum form, and boom, there's your food. They have food safe material downstairs, I think.
Probably.
And
This is one of the
and-
easier ways to get a food safe.
Yeah.
For sure.
Yeah, and you can make your own candy bars or whatever. Those are plugs for the robot bartender.
I mean, an ice cube tray is a mold. It's the exact same thing. You're able to kind of pop it out. So
Yep.
it's very, very fun.
And
there are some
there's some limits.
pitfalls.
There's strengths and weaknesses. Like doing the hammer is pretty hard. The face is actually pretty good as a thing because it's not a ton of stretch. But you got to think about how you want to vacuum form. And so the more you want to play around with that, the more we can help. If you have a big object like the face, I'm going to guess somebody probably drilled holes out through this guy's eyes so that the vacuum could be pulled through. I know it's kind of terrifying. Yeah. So that the air could be sucked out from below. Otherwise you get this like trapped set of air that wouldn't have anywhere to go down.
And there are resins, epoxy resins that have mineral filling. They're specifically engineered to make vacuum forming bucks, and there's ways to do that. It's kind of cool to see them. They use piano wire to create the holes. So they're like it's kind of wild. I'll find some photos and but it's like another example of kind of like multiple versions of molding and casting being used to make a single thing. Think of it like a tool. It's a tool.
Okay. And I think that's the end of our slides actually.
Yes.
But that brings us back through, okay, brings us all the way back to the beginning. We've gone through a very wide range of things, very, very fast. And this content is best learned by doing. So we have in the room some alginate and cups and water, and we like, if you're feeling interested and a little spunky, to make a mold of your thumbs or whatever finger you desire.
Yes,
It's fine.
whichever finger, we're not judging here.